Hello, grade 11s. We are kicking it off with some more ambiguous case stuff today. So yesterday we talked about how the different case... That's okay. I'll cut this later. I don't know why I'm telling you this, because you won't hear it. Okay, grade 11s. Hi, welcome back. We are now going to talk about how to identify which of the four cases we have when we're dealing with information provided to us that's a little bit ambiguous. We don't know if there's going to be 0 triangles, 1 right triangle, 2 triangles, or 1 oblique triangle formed. Now, yesterday in class, we kind of talked about what each of those cases look like. Today, we're actually going to talk about the calculations and how to determine what we've got. Now, something I just want to point out before we get started, as a reminder, 3 of those cases rely on finding the height of a right angle triangle, or the shortest distance from the tip of side length 1 that will reach all the way down to the bottom, the base. That's the shortest distance S2 can be in order to form a triangle. Now, that 4th case doesn't rely on height at all. That 4th case is going to be really, really nice because all we need to do is compare side length 1 to side length 2. And luckily, that information is already provided to us in the question. So when we start tackling how to identify which case we have, we're always going to start off with that diagram, right? We draw an angle in standard position, and then we draw kind of side length 2 as a nub coming off side length 1 because we don't know if it's a triangle yet, so we don't complete the diagram. If we notice that S2 is equal to or longer than S1, we automatically know we have case 4. We have 1 oblique triangle formed. However, if that is not the obvious case provided, we will have to look for the height. And again, just a reminder, backtrack a little bit. We talked about how to always find the height. That height always forms a 90-degree angle with my base. And because we have a right angle formed, we've got this right angle triangle here. And we realized we can use our right angle trig ratios, which happen to be sine. So we can use sine to help us find the height of what that triangle, that shortest distance would be to form a triangle, to then determine if our side length 2 is shorter than the height, equal to the height, or longer than the height. So that's the game plan. Now, if you don't trust me, the game plan is also stated in words right here. Okay, so as we're going through these questions, we have 5 examples to do. We're always going to start off with a diagram. Once we determine the information required to make our decision, we are also going to justify our answer. So yesterday in class, we talked about what that justification looks like. We talked about, here I'm backtracking again, this yellow highlighted information here that I'm highlighting as we go. Now, that information is our justification. That's the information I am expecting you to include when we're asking how many triangles are present. Now, remember, I mentioned that it can be written in kind of this math language that I have here, where we have our inequalities, we have our therefore symbol as a 3 dots. But I'm also totally cool if you want to write that out in words. The only thing I care about is that you're able to convey how you know what case we have or how many triangles are formed. I don't care so much in how you do that. As long as it makes sense, all the power to you. All right, let's get going. So for this first one here, I have potential triangle ABC, and I have angle A that's 80. So I'm going to start by drawing my angle. I'm going to draw it around 80 degrees. Here it is, and that is angle A. Then I have side length B, which is 10, and side length A, which is 12. Now I'm going to draw that third kind of nub of a side length because I don't quite know if it forms a triangle. I know that if this guy's angle A, then this side length is going to be little baby A. So little baby A goes here, which is 12. And we always talked about drawing ambiguous case information in ass-like fashion. Yes, I did say that on a video recording. So that means our second side length here, or I guess our first side length here, the second one that I'm drawing, will be side length B. All right. Now, when I'm drawing this, I always look for that obvious case first. If side length 2 is bigger than or equal to side length 1. And wouldn't you believe it? We've got it! Such a win. Just appreciate moments like this. Okay, so if side length 2, which is A here, is bigger than side length 1, which is B, I automatically know that I'm going to form one oblique triangle. So to justify that, I'm going to say side length 2, it's bigger than side length 1, therefore one triangle is formed. Now just a reminder, when I ask how many triangles will be formed, I'm not actually looking for you to tell me that one right triangle is formed or one oblique triangle is formed. That's not the key information I'm looking for in your answer. But remember, if you could identify when a right triangle is formed, that kind of can save you some work when we eventually start solving for those triangles. Because then you automatically know an angle is 90 degrees, and it kind of saves you some of that extra math that you have to do. All right. That's it. That's question A. Question B, we're going to do the same thing. We're going to start off by drawing that setup. Here we go. Angle K in this case is 88 degrees, so I'm drawing that really close to 90. Not really a straight line. Try again. Whoop. There we go. There's my angle K. It's 88 degrees. And I'm going to draw my little nub of a case. Nub of a little K, I should say, because that's going to be side length K. I know it's side length K because it would be opposite to angle K, and that's a measure of 8. Which means that this remaining side length 1, will be M, which is 10. Now, of course, I'm always looking for that obvious case where side length 2 is bigger than side length 1 or equal to it, but I don't got it. So, that's totally cool. I have other skills. We don't panic because we're able to determine the height. Now, if we want to, we can draw kind of that height in here to kind of know what we're talking about. There it is. But we know that to solve for that height, I would use my right angle trig ratio of sine because h would be my opposite, 10 would be my hypotenuse in that right angle triangle, and k is my angle in there. So I'm going to say sine k. Nope, sine of k. I know k. K is 88 degrees. Sine of 88 degrees is equal to my height, my opposite side length, over my hypotenuse, which is 10. Okay, solving for h, we multiply both sides by 10 to get h alone. So I get h is equal to 10 sine of 88 degrees. Again, making sure we have the degree sign every single time. And then we could plug that into our calculators. Quick, do it now! Beep, boop, bop. Wow, good work. I ended up getting an h of 9.99. Now, I don't have units here because there's no units provided to me in the side lengths, so I'm cool with not having units. You might also take a look and go, well, how do I know what to round to? I don't know. 2 decimal places are always good. But when we take a look at this, my final answer isn't determine the height. My final answer is how many triangles do I have? So when I take a look at this height, I'm not super concerned about how many decimals that you round to, because regardless of those decimals, I'm looking to see if it, how that height compares to my side length 2. So if I rounded this, not to 9.9, or I rounded this to 10 here, I'm still comparing it with my side length 2, my k value, which is 8. And in all cases, no matter how I rounded it, 8 is less than h. So, yes, I typically round to 2 decimal places unless otherwise stated. That's kind of our class-wide agreement. But just know that that rounding doesn't really make a difference in this case because it's not part of that final answer. All right. So, back to the good stuff. We notice that side length 2 happens to be shorter than h. And because h is that minimum distance we need to form a triangle, and if side length 2 is less than h, then we're going to have 0 triangles formed. Aw, that's too bad. However, when we get to solving triangles, this will be your favorite case because it's the easiest to solve no triangles. Because you're done. You've solved them all. There's nothing to solve. What an exhilarating time. Okay, your job. Pause the video. As soon as I say go. I haven't said go yet. Pause the video. Try the next 3 on your own because in all cases, you will either have a obvious case or a case where you'll have to calculate the height. And you know how to do that now. So pause the video. Try it on your own. Come back after you've done them. Go. And welcome back. Such exciting times. You've tried some work. You're back here to check our answers. So exciting. Okay. Since you've all tried them, I'm going to go a little bit quicker with my examples here. So I have a 30-degree angle, which is angle P, which means the little nub of my potential triangle is going to be little p, which is 5, and the side length 1 is going to be r, which is 10. I do not have the obvious case here because 5 is not bigger than 10, side length 2 is not bigger than side length 1, so I have to solve for the height. Now, you may have drawn in the height here, but this is not necessary for you to do if you understand how that calculation works, because it's the same every time. So in this case, I have sine of 30 is equal to h over 10. I multiply both sides by 10 to get h alone. Now, I obviously plug it into my calculator, but sine 30 actually is one of those values I already know. It's an exact value. Sine 30 is half, so half of 10 ends up being 5, which is super cool because, hey, look, our h value is equal to our side length 2. Side length 2 is equal to my height, and when I do that, I have one right triangle formed. Now, remember, I don't care in this particular instant that you know what it's a right triangle because that's not what I'm asking you, but it'll help us when we're solving them down the road. Moving on. We've got the next example. We have a 30-degree angle again, so let me draw something that's around 30 degrees. This time it's called angle E, which means the little nub will be little baby e, which happens to be 8. And d is the side length 1 left over. I don't have the obvious case. 8 is not bigger than 10, so I know I have to solve for the height. So sine of that 30 degrees is equal to my height over 10. Hey, this is the same calculation we just did above, which is convenient because I know that h is 5. Aha. As I do that, I notice this time that my side length 2 is bigger than my height, but at the same time, side length 2 is smaller than side length 1, which means it's in the middle. H is the smallest, side length 2 is the middlest. It's a word. Don't look it up. Just trust me blindly. And side length 1 is the largest. So I'm going to put less than signs there because H is less than side length 2, which is less than side length 1. Of course, you could write this as 2 inequalities and just write and in the middle. So side length 2 is bigger than the height, and side length 2 is less than side length 1. Totally cool. And when we have this, we have 2 triangles that are formed, which is super exciting. All right, last but not least, this question here. Hey, a 30 degree again? What kind of little creativity does the person who made this? Just kidding. This is beautiful. I have y is 30 degrees. Little baby y, this nub is going to be 12. And that means little baby z goes here. And I look for the obvious case, and we've got it! Side length 2 happens to be greater than side length 1, meaning that one triangle is formed. Exciting times. I know. I'm excited too. Well, that's it. We've done it all. We have literally all of the skills we need to complete this practice. Now, off you go into wonderful practice land, where you, of course, check all your answers on Teams when you're done. Yeah, and that's it. Have a great day. Bye.